Hello and welcome to the ASA, CSSA, and SSSA Journal webinar series. I'm your moderator, Romulo Lolato. I'm the current Science Communicators Editor for Agronomy Journal. Thank you for taking the time to join us today. We're excited to continue this monthly webinar series which features the latest research published in the Tri-Society journals. Before we begin, I'd like to mention that questions can be entered in the Q&A section, and we will address them at the end of the presentation. The webinar will be recorded and the recording will be emailed to all attendees after the session. Without further ado, I'd like to introduce today's speaker, Dr. Tandewin Nleya. Dr. Nleya is a professor in the Department of Agronomy, Horticulture, and Plant Science at South Dakota State University. Dr. Nleya has over 10 years of experience conducting research on dryland cropping systems in the Northern Great Plains, including the incorporation of cover crops and oil seeds in dryland rotations. Today, Dr. Nleya will speak about canola growth and yield stability. Faced with agronomic and environmental constraints, how can U.S. canola production increase to meet the domestic market demands? Dr. Nleya's paper on this subject was recently accepted, and it's scheduled to be published in an upcoming issue of Agronomy Journal. Dr. Nleya, welcome, and the floor is yours.
Thank you very much. Hello, and thank you for attending my seminar today. I'm going to be talking about canola, which is an oilseed crop. The title of the talk is Growth, Yield, and Stability of Canola in the Northern Great Plains. So canola is grown all over the world, and it is the second largest oilseed crop after soybean. And we see that in recent years, it's been in growing demand for its high quality oil, which is low in saturated fats and high in omega-3 fatty acids. The crop has several uses. It can be used as a cooking oil. It can be used as a salad oil, or the oil can be extracted for biofuel, biodiesel, or jet fuel. And after oil extraction, the meal is high in protein and therefore can be used in livestock feed. So there are so many uses for the crop. And on this slide, Canada is in canola yellow. Why? Because actually canola was developed in Canada. It was after the Second World War when scientists were looking for high quality edible oils. And the breeders working in Canada came across a cultivar of rapeseed with low erucic acid and low glucosinolates in the seed. And they used that cultivar to develop canola, Canada oil. That's where the name came from, actually. So now you can see Canada continues to be a major player in world canola trade. It exports canola to different parts of the world, here in the US, in Mexico, in Asia, in Europe, although Europe also produces a lot of canola. Here in the US, production has been increasing, as you can see in the slide, since 1991. So we've seen increase in production, but still we only produce 1/3 of what we use in this country. And most of that is in the Northern Great Plains, North Dakota, producing 80% of the canola. And the remaining 20 comes from a number of states, including Oklahoma, Idaho, Montana, Minnesota, and Washington. So as you can see, there's great potential for us to expand production to meet the demand. Otherwise, we'll keep on importing a lot of that from Canada, of canola oil from Canada. Moving closer home to South Dakota, you can see we grow very little canola in this state, only about 200 hectares, and according to USDA and us. And most of that is grown in this northwest corner here in these two counties. So there's potential we think, to expand canola production, though, in the state, especially since the crop is similar to wheat, and we grow a lot of wheat in this state, over maybe 500,000 hectares of wheat. So those are potential areas where we can grow canola in rotation with wheat, and mostly it's in the western side of the state, I'll talk about that a little bit later. Why is it important to increase canola production in South Dakota? Because then we'll give those growers who are in that drier parts of the state crop options. They grow mostly wheat and some land remains under fallow, and then we'll reduce that land under fallow, which is and also canola provides a very important ecosystem services. During the flowering time, there are like lots of insects are attracted to canola bees, so that could be an important source of food for pollinators. So the objective of the study then wanted to evaluate the genotypes, the canola genotypes that are available out there. Now the breeders have come up with early maturing types to see whether they will fit production in South Dakota. We evaluated them for both growth and yield, and we did that in 2 agroecological zones, one in western South Dakota, which is a dry environment, and another one in eastern South Dakota. In western South Dakota, as I said, is dominated by winter wheat, and usually land remains fallow for quite 14 months. So that's a potential area, a potential niche for canola for us here. In eastern South Dakota, the dominating rotation is corn soybean, but we believe that some growers may want to diversify, and those want to diversify can also potentially include canola in the rotation. So in terms of climatic conditions, as you can see in this slide, the climate in this on the western side of the state is actually hot summers, humid continental, and low rainfall and high temperatures. And this is the area where I said is dominated by winter wheat under no-till production and long fallow periods. In the eastern side of the state, the site is near where I am here in Brookings, humid continental climate, moist and cool temperatures, warm summers, and here the dominated cropping system is corn soybean rotation. So specifically, that's where the sites were located, Aurora Research Farm in Brookings, and Central South Dakota, the Dakota Research Farm. And the soil type at both locations was a clay loam. In terms of tillage, the previous crop in Brookings was wheat, and we use conventional tillage practices here, whereas in Pierre, previous crop was corn, and we used no-till practices because that's what they practice in that environment. So here I'm just giving you how some of the field management and the experimental design. You see, we were planted in May 18 here in Brookings in 2019, and in May 8, a little earlier in 2020. This is in Pierre, May 3 and April 28 in 2020. And we try and go in as soon as we're able to go in spring when it's dry enough for us to go and the snow is off the ground. And for weed management, we used a pre-plant application. And for nutrient management, really we applied nitrogen at a rate of 112 kgs per hectare and sulfur 28 kgs per hectare. And we split the applications, half at planting and the other half at flowering. The design was a randomized plot, and with plot size 1.62 by 9.4. We had 10 entries in 2019. I'll be showing you in the next slide, and 12 entries in 2020. These are the entries. These were provided by private companies, okay? So I provide some information about them. This is where the companies that provided them, and it shows the herbicide tolerance, but I want you to pay attention to maturity because that's what is critical for our environment. We want early maturing ones that can flower early and escape drought, which we often experience mid-season, and I'll be showing you in the results. So you see we had some early ones, medium maturity, according to the ratings of the company. So we're just using their ratings and the late maturing ones. and each company, maybe the rating is different from one another. So what did we collect in the field then? We collected days to flowering, plant height, and stem lodging. And in yield components, we had pods per plant, seed yield, 1,000 seed weight, seed oil content, and seed oil yield. I won't discuss all these traits given the time limit, but the paper which was published, if you want details, you can go there and look at. So for statistical analysis, we use the ANOVA in the RStudio and use LSD to separate the means. And then for the G by E interaction, we use the additive main effect and multiplicative interaction analysis. That's a mouthful. I'll just call this an AMMI in the next few slides. That's what we use for genotype by environment analysis. So on looking at the results, I wanted to start by showing you the weather at the two sites in the 2 seasons of growth. I want to pay attention that at both locations, 2020 was drier than 2019. And here in Brookings, you can see 2019 was closer, similar to the long-term average, but 2020 much drier. And in particular, in the beginning of the growing season, when we're preparing for planting, it was very dry. Okay, that will, when I explain the results, that will come into play. If we look at Pierre on the other end, it's already a drier environment, less rainfall, and both growing seasons were drier than normal average, and they will be very dry April, May. So again, that impacted the results. And the boxes I have here actually show the temperature. Canola is very sensitive to temperature during flowering, pod filling. If the temperature is above 26 degrees, the flowers are bought and the pods drop. So we pay attention, especially in 2019, it was very hot. And in Pierre, both years, it was really hot during that period of flowering, pod filling. Now let's look at the results, starting with Brookings in 2019, where it was wet, relatively wet, and close to the long-term average. This is how the yields looked like. I grouped them according to maturity. You can see that the early maturing genotypes yielded greater than the medium and late maturity. What about in a year where it was slightly it was drier? We saw the opposite. We saw the early maturing one suffering much more than the medium and late maturing. The best yield we got from long-term maturity. How do we explain this? We think is related to, as I said, the dry period, inadequate moisture during that April-May planting. The early maturing genotypes flowered early when it was hot and dry, so they lost those pods, aborted the pods and some of the flowers, so the yields were lower. I mean, in 2020, okay. Whereas in 2019, because of that, the conditions were conducive actually for early maturing one in terms of weather pattern, but then late in the season, we got a lot of rain, especially in end of July to August. So the late maturing ones were lodged a little bit more, and then we had, because canola is indeterminate, we could have continuous flowering and lodging that impacted the yields. Okay, so that's why we had better yields from early maturing in 2019. In 2020, it was the opposite, dry early spells, early ones flowering when it was very hot, losing flowers and pods, whereas the late maturing benefited for late season rain, and they were able to perform better than the early maturing ones. Now let's look at the dry environment in Pierre. What happened there is I give you the blue bars are for 2019 and the orange one for 2020. And if you just look, a glance at these will show that in 2019, really, whether the genotype is early maturing, medium or late, the yield seems to be about the same, but you can see that the early maturing ones in 2020 yielded poorly. Irrespective of the cultivar, you can see here, they all have lower yields compared to 2019. And this is how it looks like when we summarize the results according to growth habit. You can see that the early maturing ones suffered a lot in 2020, yield very low. They flowered in Pierre, it was really, really hot during this time. And the flowers, most of the flowers aborted. But there were no differences between the mid and late maturing ones. And in 2019, all the bar chart shows all the three groups performed about the same. So really that dry period in early May and in April, May really impacted the early maturing genotypes, canola genotypes in 2020. Now, the next thing we wanted to do is to figure out whether there is genotype by environment interaction, how it impacted the performance of the genotypes. Some genotypes really adapted to specific environmental conditions, especially we're interested in those drier part of the states where we intend to grow, if we were successful to grow most of the canola. So for this, we use again, the additive main effect and multiplicative interaction, AMMI analysis. And then we focused on 3 traits which were collected in all those 4 environmental conditions: pods per plant, 1,000 seed weight, and seed yield. And for genotypes, we also focused on those that were present in every single year. Okay, because we're really what we get from we only depend on what the companies provide us. For these ones were common in those 4 environments, so we use them for this analysis. So the AMMI analysis actually combines analysis of variance, which I used earlier on, with principal component analysis. Okay. So the first part of the analysis we are seeing here is that ANOVA analysis. So we look at the environmental effects, was very significant for the 3 traits we're dealing with, but genotype just for only 1. And we saw there was a significant G by E interaction again, okay, with genotype, G by E explaining most of the variation we were seeing. So with that, we decided to split our genotype by environment interaction into principal components analysis to try and understand what's happening, how these genotypes are performing in each of one of these 4 environments. And this is what we got. We found that the first principal component actually explained most of the variation for the 3 traits: 84.4% for pods per plant, 76% for 1,000 seed weight, and 62% for that. So with that, then we wanted to try and understand and to try and help us interpret this interaction. We then looked specifically on that first principal component analysis using biplots, which is a way of actually visualizing, how the genotypes performed in each environment. It gives us a way to see in a multidimensional way. So there is a biplot. So we have a principal component 1 on the right for seed yield and the seed yield at the bottom. The vertical line in the center here is the grand mean. So that's the mean or yield considering all the 4 environments. And B19, it will be Brookings 2019, B20, Brookings 20, and there's Pierre 19 and Pierre 20. So looking at it, then you see that Brookings 19 and Brookings 20 were more favorable for the growth of the crop. The yields were above the grand mean, whereas Pierre environment had yields below the mean. That's one thing. The second thing we're looking for is for stability. The closer these are the red numbers are genotypes, and they are shown at the bottom of this slide. You can see the closer the genotypes are, or the points are to the horizontal line, to the center horizontal line, the more stable the genotypes are in that particular environment for the trait in question. So you can see the further away they are, the more unstable they are. So you can see in this Brookings 2020, we see the two genotypes that were stable were CS 2300 and CS 2500. Both of them are late maturing types. This is L40, also a late maturing type. So these are the ones that were stable and high yielding were these ones. In Brookings 2019, although the conditions were favorable, we think that we don't see any genotypes adapted to this environment. Why? Because of the problems of late season rain and lodging and all those problems. There is Pierre 2019, we see more genotypes, yield below the grand mean, but more genotypes adapted to that environment. These are all, these four are all early maturing genotypes. NCC 101S, L233P, CS 2100, and 92SC. So those are early maturing that are adapted to there. Here, this P20 was very harsh environment, dry environment, you see, lower yielding, less than 1,000 pounds per hectare, and really no genotype adapted to that environment. This is a quick look at number of posts per plant and 1,000 seed weight. You see, again, the same things apply. You see Pierre 2019 and Brookings 2019 more favorable to pod production, and a few genotypes with pod number above grand mean. But with the Brookings 2020, those were the dry environments, both of them less favorable to pod production. The scattering here, these are not very close to the horizontal line, so you can say maybe they're just, these traits shows that it's influenced by environmental conditions more, and we couldn't really pick up any very stable in terms of pod production. This was true again when we looked at 1,000 seed weight. You see Brookings Pierre 2019, Brookings 2020 seed weight, more positive for seed size. That means larger seeds here. And Brookings 2020, all those had seed weight above the grand mean. And again, there's all the scattering showing that there's really, they are influenced by each environmental conditions, not clear, except this one here, which seems to be more stable. So really, I'm coming to the end of this talk. The idea here is, as I showed you, this area here, which grow in the west of the state, which where we grow wheat mostly and have followed periods of time, is the area where we're hoping that we can grow canola, and in western South Dakota, and hoping that a few farmers also where corn and soybean dominate can grow that. But our results, as I discussed them, shows that it's the early maturing canola genotypes that are adapted to these dry conditions, but the yields are very low. Okay. Eastern South Dakota is more similar to where canola is being grown in North Dakota as well as in Canada. We found that there, the late maturing canola varieties have stable and high yielding. But since really, if we are to grow canola in the drier parts, like we intend to do in South Dakota, then I think we should come up with genotypes that are adapted to these very specific environmental conditions. The breeders should come up with cultivars that maybe even screen them in this environment to come up with those that can be high yielding and profitable, as well as resilient to these very environmental conditions with inadequate moisture and sometimes unfavorable growing conditions in terms of soil moisture and temperatures. Thank you very much. I'll end up by acknowledging my sponsors, South Dakota Oilseeds Council, North Dakota Central Canola, and our experimental station here.
Very well. Yeah, thank you, Dr. Nleya. Appreciate the presentation, a lot of good information. We're going to move on now to the questions and answers portion of the webinar. So if you could answer some questions from our attendees, that would be great. For the attendees, if you haven't already, please type your questions into the Q&A section, and I will be relaying them to Dr. Nleya. Dr. Nleya, we've got a few questions here already. First, from David Kendra, did you see differences in diseases and disease severity between years and between maturity groups?
No, that's a good question, actually, because we had our pathologists look through this. Because maybe we don't grow much in terms of canola, we don't see many diseases. We didn't see many diseases, especially in Pierre is very dry, really. We had insects, chinch bugs were the problem, and flea beetles, especially under dry environmental conditions, but we haven't seen any diseases.
Thank you for the response there. We've got a question from Sharon Clay. If I was a grower in South Dakota, how can I determine which type of canola to grow, since I don't know whether the weather is going to be dry or wet? And so how does a grower go about determining which type of canola to grow?
This is a very good question, actually. So that's why it's true for any crop to usually you don't know what the weather conditions are going to be. But if, let's say, you are a grower in central to western South Dakota, I would say you go with the earliest maturing you can get. Okay, and unfortunately, the breeders are not focusing on drought tolerance. Maybe in the future they should look for that early maturing one. If you're in the west. If you're in the eastern part of the state, maybe you go with a later maturing one, because that will give you a better yield potential.
Okay, thank you. And another question that we had here from David Kendra: did environment and maturity group impact pod shattering?
Pod shattering, well, actually, it depended on if we did get a hailstorm once. Okay, environmental conditions, hailstorm, environmental windy conditions at when they are maturing could be an issue too. When it's very windy, we get lots of shatter. But I mentioned that the breeders actually are paying attention to that. So most of those genotypes I showed you are already bred for pods not to shatter. So they put in some effort in breeding to reduce shattering of pods.
Okay, thank you. And perhaps one last one here. What's and this is a more general question, right? But what's the difference in relevance of selecting and recommending genotypes based on broad adaptation versus specific adaptation?
Yeah, why in this paper, I remember I argued for specific adaptation, because if you think of it, we are trying to expand the canola to environment which is typically not used to grow canola in North Dakota, in Canada, cooler conditions. So maybe they can use wider adaptation to develop genotypes that can grow in a wide range of areas. But because we are focusing in this area with inadequate moisture, hot, dry conditions, I think they should be looking for specific adaptation genotypes that will do well in these very specific conditions we are focusing on.
Very well, thank you. I don't see any other questions in the chat here. I believe that they were mostly answered. If any attendees have any final questions, now is the time to put them on the Q&A there. Otherwise, I'd like to thank you again for joining us for today's webinar, and also thank Dr. Nleya for sharing their research. As a reminder, the recording will be made available and sent to all attendees soon. So thank you very much again, and have a good day.
Thank you very much.
Thank you. Goodbye.
Bye.